Math 3, Unit 4 review notes. We have rational functions. All we're going to be doing here is factoring and simplifying. Remember that when you have a binomial or a monomial, you can only cancel them if they are exactly the same in terms of binomials, but monomials you can reduce because you can divide by the same number. So please be careful on these. So all we're going to do is factor. So on A, is there anything I can do there on the top? Very good. We can take out a 6, and I'm left with z plus 2. In the denominator, can I take out a GCF? No. And so we are going to try to factor it by using our trinomial factoring. And so we go 2 times 6, which is 12. So my multiplication is 12, and my adding is 7. Am I able to use a shortcut? No. So we have to write this one out. So we will write this as 2z squared, but instead of writing 7z, what are we going to write? 4 and 3. Good. Because 3 and 4 both add to be 7, multiply to be 12. So that means we have plus 3z plus 4z plus 6. And if you change the order with 3z and 4z, you will still end up with the same answer at the end. Okay, so we group these into our 2 groups. What is the GCF of the first group? So for me, it's just z. And I'm left with 2z plus 3. In this group, what can I factor out? A 2. So for me, I can factor out a 2, and I'm left with 2z plus 3. If you had flipped those around, each of your parentheses would have been z plus 2. Okay? So since the 2z plus 3, those are like, that's now my GCF. And so we have 2z plus 3, and my other parenthesis that has the leftover pieces is z plus 2. Can anything reduce? Good. So we cancel these out, and we have 6 over 2z plus 3. Can I reduce anything here? No, because this is a binomial, correct? And so in order to reduce something, it has to be exactly the same, or you'd have to factor something out of this, and you can't. So don't try to reduce here or anything like that. This is your answer. Any questions? Okay, B. Can the top be factored? Good, difference of squares, because 16 is really 4 squared. So when I factor, I get what on the top? Good. Now, in the denominator, are these the same? So this is y minus 4, and this is 4 minus y. Here the y is positive, here the y is negative. How could I make it so that they're the same? Good, you can take out a -1 from one of those parentheses. So if I take out a -1 from this parenthesis, the 4 becomes negative and the y becomes positive. Do you see how they match now? So that's only if they're opposite signs we can do that. And so this answer, you can just bring the negative up to the top in front of that parenthesis. So we end up with -y plus 4. You could also write that as -1. Okay, any questions? All right, this next example is similar to these other 2. Do you guys feel like we need one more like that? Okay, so we're going to move on to D. This is multiplication, but if you notice here, we have to factor 4 different things possibly. So the top here, can I factor that? Good, we can take out a GCF of 3x. So we have 3x, and we are left over with x plus 3. Over here, can I factor anything of the top? No. So we just have 2x plus 5. This denominator, can I factor out a GCF? No. So that means I'm going to end up trying to factor using trinomials. And so we're going to multiply. 2 times 15 is, so my multiplication is 30 and my adding is 11. What numbers can work? Good. Can I use my shortcut? So we're going to write that out as 2x squared plus 6x plus 5x plus 15. From there we'll group. What's my GCF at the first group? And we're left with? Good. And the GCF at the second? And we're left with? Good. So when we end up finally factoring that, what goes in the denominator over here? Good. Does it matter what order I write it in? No. And we all understand that this here is a GCF, so that's why we take that out and it becomes just 1x plus 3, and then everything that's left over is our second parenthesis, 2x plus 5. Just like here, how I'm taking out a 3x, and that's my leftover. Here, I'm taking out the x plus 3, and that's my leftover. Okay, the denominator here, can this be factored? Yes. How do I factor that one? Cubes. But we have to write 27 as a cube. So when I do that, what's my first parenthesis here? Bless you. X plus 3. Is everybody okay with that? So we're looking at this denominator. I changed 27 so it was a cube. And so my first parenthesis, we take off the cubes and I have x plus 3. Next, what am I going to do? I'm going to write out x 3 times and 3 times. So x times x times x times 3 times 3 times 3. Group them. And what does that parenthesis become? Good. X squared minus 3x plus 9. X times x, x squared. 3 times x, 3x. 3 times 3 is 9. And this is always positive, and this is the opposite. Okay, so now everything's factored. Do I see anything that can reduce? X plus 3's. 2x plus 5. Anything else? So anything on the top can reduce with anything on the bottom. So as long as it's on the top, it can reduce with something on the bottom. Okay? Anything else? Okay, so that means my final answer is 3x over x plus 3 and x squared minus 3x plus 9. It is not factorable. You'd have to use the quadratic formula. So it's not going to reduce anything. Okay, so let's go to E. Let's try another one. This one, though, is what? Dividing. And when we have division, we need to flip it. So that's where our KFC, keep this one the same. Flip this one and change the sign to multiplication. So I'm going to start factoring. On the top here, what multiplies, oh wait, before that actually, what do I need to do? Good job. So we're going to take out an x, and we're left with x squared minus 6x plus 8. Can that be factored further? Yes. So this one has multiplication of 8 and adding to be negative 6. And what numbers will work? Good. Negative 4 and negative 2. So I'm going to rewrite this here at the bottom. We have x, x minus 4, x minus 2. Okay, any questions about that? Okay, next let's move to this denominator. So on that one, my multiplication number is 16 and my adding is -8. What will work? Good, -4 and -4. They add to be -8, multiply to be positive 16. So my denominator, we're going to write that as x minus 4 and x minus 4. If you want to write as x minus 4 squared, you can. What is going to go on the top, though, from over here? Good, your GC, your 10x squared one. And can I take out a GCF there? Which is 10x, and I'm left with, can that factor further? No, so I'm going to write that where? Top or bottom? Good. And what about this x cubed minus 8? Can that be factored? Yes, but we have to change 8 to what? 2 cubed. What will be my first parenthesis? X minus 2, good. Then what do I do? Good, x times x times x, and 2 times 2 times 2. We group them, and what ends up going into my parenthesis? Great. Any questions on that? Okay, so anything on the top can reduce with anything on the bottom. Do we see anything that can reduce? X minus 4. Another x minus 4. X minus 2. Anything else? Okay, so pay attention to what's left over. So we have those 3 things, and what does that end up becoming? Good, I'm going to write this over here. So 10x squared over x squared plus 2x plus 4. Okay, any questions? All right, F. Now this is what? Addition. The only way to add fractions is if they have what? Same denominators. Do these have the same denominators? Yes, so our denominator stays the same. We have x squared plus 5x minus 24. We can now add the tops, because since this is adding, this would stay a positive 2. And so what do I end up with? 5x minus 15. Now we need to check to see if we can reduce. Can I factor anything here? Yes, there's a GCF on the top, which is 5, and I'm left with x minus 3. The denominator, we are looking for something that multiplies to be negative 24 and adds to be 5. Good job. 8 and negative 3. Can I use my shortcut? How come I can use it? Good. The coefficient is 1. Can anything reduce? X minus 3s. So my final answer is good. Any questions? Okay, are these denominators the same? What do I need to do? Factor out a -1. When I factor out a -1, let's say I take it from the denominator here, that 2 becomes a negative and the x becomes a positive. Do you remember what we're supposed to do with that -1 that we take out? Bring it to the top. If there was multiple terms up here, I would distribute it, but in this case, there's just a 10, so that 10 becomes a negative, and since I brought that negative to the top, I could just make that a plus. Like that negative's no longer on the bottom because I took it and just brought it to the top. Remember, when you ever have fractions with a negative, it can go with the top or the bottom. It doesn't matter. It just has to be negative. Okay? So now we have like denominators, and my denominator is x minus 2, and so what's going to be on the top? Good, 5x minus 10. Is there anything that can be factored so I can try to simplify? Good, what can be taken out? A 5. So we factor out a 5, and I'm left with x minus 2 over x minus 2. Can anything reduce? x minus 2, so my answer is 5. Any questions? Okay, this one looks pretty easy, but what do we have to do? You have to distribute your negative to everything on the top of that second fraction. So this becomes a negative, and this becomes a positive, and this changes to positive. So now what do we end up with on the top? Good, so when we're combining like terms, because I can combine like terms right now because they have common denominators, we have 5x minus 3x, which is 2x plus 2. Can anything factor? Good, GCF of 2. We're left with x plus 1 over x plus 1. X plus 1's cancel because they are like, and my answer is 2. Yes?
Why did you change it to the top to negative?
So when you are subtracting, this was originally a subtraction sign. In order to subtract the fractions, you have that minus sign is going with everything because it's like subtracting that fraction. And so you have to make sure that each of those terms has a subtraction sign. So it's easier to just distribute it than have it in the front and know that you're subtracting each of them. Does that make sense? Okay. All right. Okay, same thing on I now. Are those like denominators? So what do I do? Very good. Distribute that negative. So the 9 becomes a negative. This becomes a positive. Why wouldn't I distribute it to the denominator? It would change. Yeah, it would make it so they weren't the same anymore, right? And so the negative either is going to go at the top or the bottom, so it makes a lot more sense for it to go at the top because you want to keep your like denominators. Okay, so we end up with 3x minus 9 over x squared plus 4x minus 21. Can I factor that at all? Yes. What can I take out of the top? A 3. I'm left with x minus 3. The denominator, what multiplies to be negative 21, and what adds to be 4?
7 and negative 3.
You guys are good. So we get x plus 7, x minus 3. We can reduce the x minus 3's, and so my answer is 3 over x plus 7. Okay, on J, you notice that they are not like denominators. What do you do on that? Good, you have to find the LCD. What would the LCD be on this problem? Good, x plus 1, x plus 4. So we rewrite these with the common denominator, x plus 1, x plus 4. Oops, 4, not 5. X plus 1, x plus 4. Okay, now what? Good. So this one already has an x plus 1, so what does it need? An x plus 4. So what we're doing is we're actually multiplying the top and the bottom by x plus 4. When we do that, though, I have to distribute that 3 because we're going 3 times x plus 4. So it ends up making what? 3x plus 12. Good. What is this fraction missing? X plus 1. So whatever we do at the bottom, we also do the top. So we're multiplying by x plus 1. But this is really a what? A negative 5. I'm going to put the negative here and make this a plus, which means that this is actually a plus now. And so we'll distribute the negative 5 through. So negative 5 times x is negative 5x, and negative 5 times 1 is. Then we can combine like terms. 3x and negative 5x makes negative 2x, and then 12 and negative 5 makes 7 over x plus 1 times x plus 4. And we can't factor anything out, so that's my answer. Okay. I don't feel like we have to do another example like this. This one, just real quick, if you were to factor this denominator, you have 2 times x plus 10, or sorry, 2 times x plus 5. So that means that this side just needs a what? A 2, and whatever you do to the bottom, you do to the top. And so you'd go through. This one, if you wanted to work through it, the final answer ends up being 5/2 once you reduce. But, yeah. Okay. On L, what are we going to do? Notice this one is different. What's different about it? Very good. It has an equal to sign. Do you guys see that? The other ones we were just simplifying. Whenever you have an equal to sign, what can you do? Nobody knows? You find the LCD, and then what do you do? Multiply it out, and then what happens? There's no more fractions. There you go. You guys know it. Okay, it was not a trick question. Okay, so what is my LCD? X times x plus 2 is my LCD. Very good. So next to every term, I'm going to multiply x times x plus 2. On the first term, what happens? Very good. X's cancel out, and I'm not gonna multiply right now. I'm just gonna write this as 9 times x plus 2, and I'll distribute in a minute. Okay, what happens with the next fraction? Okay, and what am I left with there? And don't forget that minus sign is there, so minus 12x equals, and then what happens on the last one? Good. X plus 2's cancel, and 3x times x is? Very good. Okay, so now we're going to simplify. I'm going to distribute the 9 through. 9 times x is 9x. 9 times 2 is 18. And then I have minus 12x equals 3x squared. What do you think we're going to have to do? Okay, so there's a lot of things, but because there's an x squared term, we know that we're going to end up having to factor, right? And anytime we factor, it has to be set equal to 0, which I heard some of you say. And then also I heard someone say we could what? So if we're combining like terms first, what's 9x and negative 12x? So we have 18 minus 3x equals 3x squared. Which side should I move everything to? To the right. Why? Good. You always want your highest exponent to be positive. So you're always going to move it to the side where it's going to keep that positive. So I subtract those. I end up with 3x squared plus 3x minus 18 equals 0. And you can have your equals 0 on either side. What can I do to factor? Take out a 3. Very good. And you're left with x squared plus x minus 6 equals 0. How can I factor that? Good. So the multiplication number was negative 6. The adding number was 1. And so 3 and negative 2 is what works. So I'm just going to write it up here. So we still have our GCF of 3, and then I have x plus 3 and x minus 2. And when I set those equal to 0, what does x equal? Negative 3 and 2. Why doesn't it equal 0? 3 can't equal 0. So when I set 3 equal to 0, that doesn't work. So it's not a solution for x. Now, there's one thing I forgot to write at the top, and that was, what are my extraneous solutions? So what would make these denominators equal to 0? 0 and negative 2. Do any of those answers match the answers I have here? Nope, so I'm good. Both of those work. Yes? You set each of the denominators equal to 0. So if I set x equal to 0, I get 0. X plus 2 equal to 0, I get negative 2. Okay? All right. M is the same idea. I'm not going to go through all of M, just know that you would need to factor this. And when you factor this, it would factor to be x minus 6, x minus 2. And so what would your LCD on this problem be? X minus 6, x minus 2. You'd multiply everything, eliminate your fractions. Also, what are your extraneous solutions on this one? Good, 6 and 2. And again, our LCD would be x minus 6 and x minus 2. And if you were to solve this one later, just for fun, because I know you guys would totally do that, the answer you should get is x equals negative 1. Okay. Word problem. Here we go. So, a group of college students rents a large house to live in and agree to evenly divide the $1,200 monthly rent. Initially, they are ex-college students. So initially, how do I write this equation? Thank you. 1,200 divided by x is correct. Then it says, but then 5 additional college students decide to join the group, causing each college student to pay $40 less per month. So, how do I write that second part of the equation? Good. Hold on right there. So, 1,200 divided by x plus 5, because now they've added more. And so now when you add more here and when you were to reduce this number, it's going to make it smaller. So in order to make it balanced, what do I do with this 40? Add 40. Bless you. Okay, any questions there? Okay, so now we have to solve this. 1,200 over x equals 1,200 over x plus 5 plus 40. What is my LCD? Good. So LCD is x times x plus 5, and my extraneous solutions would be 0, negative 5, which, if you think about it, you're not going to have 0 people, and you're not going to have negative 5 people, right? Okay. So x times x plus 5 next to every term. When you do that, the x's cancel here, and we have 1,200 times x plus 5 equals, here the x plus 5's cancel, and you have 1,200x, and then I have plus 40x times x plus 5. Yeah, so when we distribute, which I'm going to do now, 1,200 times x is 1,200x. 1,200 times 5 is 6,000 equals 1,200x plus 40x times x is 40x squared, and 40x times 5 is 200x. Okay, good. Do we notice anything? Good. Since you have a 1,200x on both sides, those will end up canceling out. Which side should I move everything to? The right side. We subtract 6,000. So when I do that, I end up with 40x squared plus 200x minus 6,000 equals 0. You can take out a GCF of 40. You get x squared plus 5x minus 150 equals 0. I'm going to tell you, for time's sake, that that factors to be x plus 15 and x minus 10. And when you set those equal to 0, what does x equal? Negative 15 and 10, but we can't have negative people. So the initial amount of people is 10. So I'm going to put 10 college students or 10 people or 10 students, whatever you want. Okay, any questions there? Okay, I'm going to try to finish this really quick. I'm sorry. All right, Huck Finn can paint a fence in 5 hours. Tom Sawyer can paint the fence in 6 hours. How long would it take them to work together? Do you guys remember how to set this up?
Yeah.
Okay, so one job for Huck Finn over 5 hours. One job for Tom Sawyer takes him 6 hours. So times on the bottom, okay, equals, we don't know how long it will take them to do this together. It has an equal sign, so we can eliminate the fractions. What am I going to multiply by to all the terms? Good. 30x would be my LCD next to every term. When I do that, here 5 goes into 36 times, we get 6x. Here 6 goes into 35 times, I get 5x. X's cancel, 30 times 1 is 30. 6x plus 5x is 11x equals 30. We divide by 11. X equals 30 over 11. If you put that into your calculator, it is approximately 2.7 hours. On your test, you can use a calculator. You can take 30 divided by 11. The answer might be 30 over 11. Either way. Okay. Last one. Are you guys ready? Okay. Remember, this tells you your asymptotes. There's an asymptote at x equals what? 2. There is another asymptote at y equals what? 1. Good job. Okay. We know that these graphs are curves diagonal from each other, but we're not exactly sure where they are. We find them by finding my y-intercept and my x-intercept. How can I find my y-intercept? Plug in 0 for x and solve for y. So y equals 1 over 0 minus 2 plus 1. 0 minus 2 is negative 2. So that means here I have negative 1/2 plus 1, which is what? 1/2. Okay, so my y-intercept is y equals 1/2. So on the y-axis, there's a point there at 1/2. Everybody okay with that so far? Okay, x-intercept, how do I find it? 0 for y and solve for x. So 0 equals 1 over x minus 2 plus 1. How do I eliminate the fraction? Multiply by the LCD, which is? Okay, so I'm multiplying each term by x minus 2. What's 0 times anything? 0 equals x minus 2's cancel, and I'm left with 1. And then 1 times x minus 2 is going to give me x minus 2. We combine our like terms. 1 and negative 2 makes. So 0 equals x minus 1. We add 1 to both sides, and x equals 1. So at 1, we make a point. And that is where one of my curves are. Where's the other curve? Yeah, diagonal from it. Okay, what's the domain? Negative infinity to 2, and then 2 to positive infinity. What is the range? Negative infinity up to 1, and then 1 to positive infinity. So remember that your range is with your y's and your domain is with your x's, and these lines are asymptotes and it can't equal those values. Okay? The vertical asymptote is what? Vertical is up and down, that's x equals 2. Horizontal is right and left, that one is y equals 1. This, if you're reading the graph, this is going down, decreasing, starts here, it's going down and decreasing. So is it ever increasing? No, so none. It is decreasing on the entire graph, which is the entire domain. So where is it decreasing? Negative infinity to 2, and then 2 to infinity. When is it greater than 0? So remember, I'm going to go to greater than 0. Greater than 0 is above the graph. Where is it greater than 0? Negative infinity to this point, which is at 1. And then it starts again here up at 2 all the way to positive infinity. Okay? So do you guys see how this is part of the graph? So above 0, negative infinity to 1, and then here it's from 2 to positive infinity. So negative infinity to 1, and then 2 to positive infinity. When is it less than 0? Oops, sorry. You can't see what I was writing. It's only less than 0, and going back to the graph, at 1 to 2. 1 to 2 is the only place. And remember that all the information you're giving is always coming from the domain, except for the range.